Let's go ahead and get started now on our lesson that involves section 9.1 and 9.2 of our book. So we're going to be talking about scatter plots and then their trend lines that go with them. So here's an example of a scatter plot. It's the same as putting a point on a x and y axis on the coordinate plane. But the only difference is they don't make a perfectly straight line like we've done most of the year. So we don't connect the dots, in other words. But sometimes the points all show a trend. They all kind of going up like this. That would be just like a positive slope. That would what we would call a positive association. And what that means is as our independent variable increases, let's say time, as time increases, and we'll call our dependent variable, we'll just say it's money this time. It could be anything, right? But let's just use time and money since that's what's used in most math problems. So as time increases, if money increases, as the time increases, as x gets bigger, if y gets bigger, that's called a positive association, right? The farther we go this way, the higher we go up this way. That's called a positive association. So negative association is the opposite. So let's say you're spending money. So as time goes by and you have savings, the more time goes by, you're spending, your savings will go down the farther we go this way. That's a negative association right there. So negative association is similar to a negative slope, right? And no association, of course, as x goes up, y is not affected at all. That's called a negative association. So an example of a negative association would be something like however many hours that you swim will affect how much you love classical music, something along those lines. And that's ridiculous, but just to show that one doesn't affect the other, they're completely separate of each other. That would be a negative a no association. All right, so let's go ahead and continue. Now we're going to talk about scatter plots today. And what I want you to notice about this table is it's just like those x and y tables that we've been doing all year, or they could have been horizontal like this, right? X and Y tables. But the thing is it's like they took half of this table, they cut it and they put it next to it. That's what this is over here. See, this is X and this is Y. And instead of keep going down here, they cut this bottom half and put it over here. So this is still X and this is still Y. So I hope you understand this is just a regular table like we are used to seeing. So if we had to make a scatter plot, then it would go back to way back when we just reviewed how to plot a point. So if my x is 50, that's side to side, and my y is 83, see where I'm getting the x and the y from? Then I would go over 50 first, over to 50, and then up to 83, and I would make 1 point. That's how I would plot this point right here, this point, okay? And then if I do 5390, I go over to about 53, up to about 90. Doesn't have to be perfect, right? Close enough. We'll get the idea. So I plotted that point. Then 5686, over to 56, up to where 86 would be about, and make that point. 5792, 5792. So as you can see, making a scatter plot is the only skill you're using there is just plotting points. That's all it is. So 60, 98, I go over 60 up to 98, make a point right there. 65, 97, I'd go over 65, about as close as I can get, up to 97, which would be around there-ish. Okay. I'm trying to make nice dots here for you guys, but as you know, I'm not real great with this tablet. And then we got 65, 103. 65, 103. So as you're doing 65, 103, quick question to you. Is this a function? Do you remember that question? Is this a function? If I have two dots lined up right on top of each other, and the answer is no, that would fail the vertical line test. So this is not a function. It's a relation, not a function. 68, 100, 68 up to 100, so right about there. And as you can see, as the height increases, so does the weight. So that makes kind of sense, right? The taller someone is, usually the more they weigh, something along those lines. But we all have different body types, correct? So it's not perfect. It won't make a straight line. But in general, the taller you are, the more you weigh. So that's a positive association there. As this increases over here, this increases over here. That's a positive association. Okay. So let's go ahead and take a look at this new vocabulary word we're going to learn right now. We're going to learn something called the trend line. In some books, some teachers, some tests will call it line of best fit. But trend line and line of best fit mean the same thing. And we're going to have this vocabulary word on our next quiz. So let's make sure we pay attention to that. So, what does that mean? Well, we're talking about scatter plots today. And we learned that if they have an association, they're either generally going up or generally going down. Um, and in that situation, if you guys took and drew a line kind of through the middle of all that stuff, that would be called a trend line. So you can find a trend line or a line of best fit by drawing a line through the middle of the scatter plots. Okay, and in that trend line, we can find the same way we found uh, equations for linear functions, which is using slope-intercept form. So let's look at an example of a trend line. So you see this data right here. If I kind of drew a line through the middle of most of them and it was straight, that would be a trend line. Or if I drew a line this way, that would be a trend line. How about my trend line here? What would it look like? And the answer is there would be no trend line. It doesn't have a trend line because there's no association. So you'd only draw a trend line if there was a positive or negative association. And then to find that, you would just take that line and take 2 points on the line like we did and find the slope, subtract your y's over subtract your x's, find your y-intercept, right? Take 1 point in the slope, plug it into this equation, solve for b. Once you have this number and this number, you know the equation. So that's how we find trend line. And we'll review that here very soon. So we have a scatter plot here, calling it a scatter plot instead of a line because it's not a perfect linear function, but we'll see if there's any type of association or not. First things first, we're going to make a scatter plot. Let me show you what it would look like if you made a scatter plot. So just like we did on the last problem, this is x and this is y. So we go over to 4 and up to 38. And as you can see, it's easy as side to side and up and down. Okay, so first I go side to side. Positive means goes to the right, and positive means go up. 1, 7 would be here. 1, 7 is right about there. It doesn't have to be perfect. 2, 16. I'm right here right now. If I lost you, 2, 16. I'm going to go over 2 and up 16. Over 2, up to 16. 16 is right above 15. Now we have 326, so I go over 3 up to 26. That would be right about there. Make a dot. 550 would go right about here. 220 would be right about there. 445 would be right about there. And 331 would be right about there now. So we made a scatter plot. So what do you guys think? Is there an association there with that scatter plot? Answer? Yep, there's a positive association. So now another skill we're going to have is find the trend line. So if we were going to find this trend line, what we would do is we would draw a straight line through the middle, trying to get through the middle as best we can. And then what we can do is we can take a couple points that are actually on the line, and even they don't even have to be one of these actual points. But we'll take a couple points that are on the line. For example, 220 is on the line, and it looks like 550 is on the line. And to get the what's called trend line, that new vocabulary word, is just another slope-intercept form. It's another y equals mx plus b. So we memorized in class what are the two things you need to find to write the equation of a line. Got to find the slope and the y-intercept. You guys remember that? How do we get slope? Subtract our y's. I'll go y minus y. And of course, this order doesn't matter as long as you keep the same order. If I subtract from the left side first, on the top, I have to subtract on the left side, this being left, this being right. and we'll get the right answer. If we switch that order, we'll get the wrong sign, right? Okay, so I go left minus right over left minus right. As long as I keep the same order, I'm good. Subtract these two. And negative over negative is positive, and it looks like I have a slope of 10. I want you to try to remember what slope is ready to change, right? So we're dealing with word problems now. So what do you think 10 has to do with anything? We got distance down here. We got time in minutes. What do you think that means? 10, 10 what? Okay. Well, it looks like distance. Normally time, and I'm trying to throw a curveball at you here, because time is always x, isn't it? In real life, time decides things. But in a math class, time could be your dependent variable. It's possible to have time as a y, and I did that on purpose this time, even though it doesn't really make sense in real life, right? Time decides money, time decides everything. But it is possible in a math class that we could have time as the y. So in this case, what this means is if you put your y's on top, remember y's on top for slope, right? Put your y's on top. We're talking about time. It'll be 10 minutes every mile. Okay, usually it's miles per hour. Time goes on the bottom. This time it goes on top. Okay, so our slope. Long story short, our slope is 10. Now we got to find our y-intercept. Where does it hit the y-axis? Well, if you do this, you see that it's kind of proportional there. In other words, if no distance has gone by, no time has gone by either. And so our b has to be 0. Our equation is time equals 10 times d. T equals 10 times d. So, again, find our slope, get our y-intercept. We could always take one of these points and use the point and the slope that we found. If that proportional relationship didn't make sense why this is the equation, then we can just do the long way that works for all problems. Take a point, take the slope that you found, and put it in y equals mx plus b. This is y, this is x, this is m, and then solve. And you can see as we solve this, as I subtract 50 from both sides, I get my b equals 0. So my equation would be y equals 10x plus nothing. Or in other words, we don't need to write this part. But for my y-axis, on my y-axis, I have t for time. That's where the t comes from. And on my x-axis, I have d for distance. That's where the d comes from. So that's why this is the answer right here. You guys send me an email if that doesn't make sense. I can try to explain it to you another way. Look at number 3. So it says, find how long it takes for this person to run 4.5 miles 2 different ways. Well, how could we do that? Well, first of all, I have an equation, don't I? So if time equals time equals 10 times the distance, or the minutes equals 10 times every mile, which is kind of weird, right? We're used to time being on the x-axis. That's the way it should be, but it's a math class, so this could happen. It says how long, in other words, we don't know t. For 4.5 miles, we know the distance d. So when I have an equation, I just put the number that they give me where it goes into the equation. Since miles is distance, I don't put it here where t goes. I put it over here where d goes. And we know that when we multiply by 10, it's the same as moving the decimal one time. So the answer would be, looks like, about 45 miles, right? Because 10 times 4.5 is 45. And what's another way we could have done it? We have a graph up here, don't we? And we use our line of best fit. And the question was, how long would it take to run 4.5 miles? Well, 4.5 miles over here, what time is the same as that? If you look over here, the time would be 45 minutes. That's another way to do that same problem. All right, and that's it for scatter plot today. We will see you guys soon.